In this video, we're asked to add polynomials, but before we take a look at adding polynomials, I want to compare it to just adding regular numbers. Let's take a look at since we're looking at a trinomial here, all of these are trinomials, they have three terms. Let's take a look at adding a three-digit number to another three-digit number. We're very familiar with doing this. We've been doing it for a long time. All you do is make sure that your place values line up, and then you add straight down. So 2 plus 8 is 10. Of the 10, I'll write the 0 here. I'll carry over the 1 to the next place value. 1 plus 1 is 2, plus another 2 is 4. And I don't have any value to carry over there, so I can just add 1 plus 3, and that's also 4. Another way of looking at that would be to understand the 112 in terms of 100, its component parts, right? 100 plus 10 plus 2, and the 328 would be 300 plus a 20 plus an 8, right? And then again, we would line those up and add them straight down, and we would end up with the same result. Well, adding a polynomial is very similar to that. If I were to look at the first one, number 48, it says add the quantity 11y squared plus 6y minus 3, and add to that 9y squared minus 2y plus 9. And what I can do is I can take this quantity here and just rewrite it. I'm going to say, well, I'm going to put this down here and rewrite it as 9y squared minus 2y and add to that 9. I'm just going to take all of that and rewrite it down there. As long as I rewrite the like terms together, notice that this y is a y squared. This y doesn't have a degree. It's a degree of 1. It doesn't have an exponent. And this doesn't have a y at all. So in order to add polynomials, you can only add like terms. And like terms have the same variable and the same exponent. And that's how we identify like terms. And those can be multiple exponents and variables. So once we have this written, one number under the other number, basically, we can just now add. Adding 11 to 9, if I have 9 of something and I add 9 more, 11 of something, and I add 9 more of that something, I now have 20 of those y squareds. Here I have 6 y's and I'm taking 2 of those y's away, so I have 4 of them left. I have 4 y's left. And I start with negative 3. I like to tell students, you owe me $3 and you have $9 to cover it. So you have, once you pay me the $3, you have $6 left in the chamber or in your wallet. Okay, let's take a look at number 50. Number 50 says, stay with white here. Number 50 says 8x plus z minus 7y, the quantity, plus another quantity, 5x plus 10y minus 4z. Now here, we're going to have to, let's use the same strategy. And whereas last time we wrote the quantity, the top quantity, this quantity underneath this quantity, we can just as easily write this quantity underneath here. But remember, notice this says x, z, and y, and here I have x, y, and z. And remember, in order for this to work, I have to put my like terms together. So 8x goes under the x term, the z goes under the z term, and my negative 7y goes under the y term. So basically, I've taken all of this and rewritten it down there, and now I just add straight down. 13x plus 3y minus, because the 4 has the higher absolute value, minus 3z. And so if this is my answer up here, then this is my answer down there. The only difference between the first one and the second one was that I had to rearrange some parts. Let's take a look at number 52 and look at just a slightly different strategy. 52 says the quantity x squared minus 5y squared minus 9z squared plus the quantity negative 6x squared plus 9y squared minus 2z squared. Well, a different strategy would be just to keep these all in line rather than write them one on top of the other, which is a fine way of doing it. But another way to do it would be just to look and find in the line, look and find your like terms. And I like to circle them once I'm looking in like terms. I just like to circle them, and because I have the advantage of having different colored pens here, let's take a look. What happens when I circle my x squareds in blue? So I have an x squared there, and I have a negative 6x squared there. And remember, the signs are the operators. So here I have a negative 5y squared. I don't just have a 5y squared. I have a negative 5y squared. And that maps over here to this positive 9y squared. And then finally, in the end, I have this minus 9z squared. And that's going to go with my negative 2z squared. So remember, like terms have to have the same variables and the same exponents, and that's what I've got here. So now I can just combine my blue ones. My blue ones are the x squared minus the 6. So if I have one of something and I take 6 of it away, then now I have a negative 6 of that something. With my y squareds, if I have a negative 5 and I add to that 9, then I have a positive 4y squared. And finally, with the negative 9z squared minus 2z squared, that'll just be a more negative 11z squared. And that's my answer. That's adding polynomials. So let's take a look at subtracting polynomials now. What happens when I subtract polynomials? Well, let's start with the quantity 8y plus 1, and we're going to subtract from that the quantity negative 5y minus 2. So let's do that same inline strategy, but the difference here is now instead of having a plus in between my quantities, I have a minus. And remember, whenever I see a negative in front of a quantity, I imagine there's a little 1 here. There's an imaginary 1 there. And now I have to distribute that 1 in. Because remember, subtracting is only adding the opposite. So if I have 8y plus 1 here, I'm going to add the opposite of these quantities. So the opposite of negative 5y is a positive 5y. The opposite of a negative 2 is a positive 2. I have like terms here and here. And I have other like terms here and here. So 8y plus 5y is a 13y. And 1 plus 2 is a positive 3. And then that's my answer there. Let's take a look at number 68. And let's go back to our earlier strategy as we do this. Let's go back to our earlier strategy, negative 9y squared plus 4y plus 8 minus 4y squared plus 2y minus 3. Let's go back to our earlier strategy of writing this down below here, but remember, let's add the opposite now. So the opposite of a 4y squared is a negative 4y squared. The opposite of a 2y is a negative 2y. The opposite of a negative 3 is to add 3. So basically I just took all of that and put it down there, and now I just add straight down. 8 plus 3 is 11. 4 minus 2 is positive 2. Oh, that's a positive 11. Let's give myself some room here. That's a positive 11. 4 minus 2 is a positive 2y, and negative 9 minus 4, that's even more negative. That'll be a negative 13y squared, and then that's my answer there. Let's try number 70 just for fun. That's the quantity z plus 8x minus 4y minus the quantity 4x plus 6y minus 3z. And let's use this same strategy again. Let's just rewrite it by adding the opposite. That's what minus says, add the opposite. So my 4x becomes a negative 4x. My 6y becomes a negative 6y. And my negative 3z becomes a positive 3z. So I just took all of that and put it down there. Z plus 3z is 4z. 8x minus 4x is plus 4x. And minus 4y minus 6y is minus 10y.